Good afternoon. Welcome to this lunch seminar from Southeast Michigan Informs chapter. We are delighted to host Professor Dmitry Ivanov from the Berlin School of Economics and Law today. And this is being recorded as a webinar that we hope to post to the Informs YouTube channel soon, after we're done, obviously. But because of that, we won't see the participants' videos. We will have a Q&A time afterwards. So if you put your questions in the Q&A, then we'll have our panelists pick out some select Q&A questions, and we'll save some time for that at the end. But I want to jump in. I know everybody's on their lunch break here in Southeast Michigan anyway. Professor Ivanov is obviously not. He is from the Berlin School of Economics and Law, a leading scholar whose research on supply chain resilience and digital supply chain twins has shaped both academic and industry thinking. His work, including the viable supply chain framework and the ripple effect concept, has guided organizations worldwide in designing adaptable, intelligent supply chain networks. I know that he's worked with some companies here in Southeast Michigan, which is what prompted us to invite Professor Ivanov today. So today, Professor Ivanov will share insights on how supply chains can survive and thrive amid large-scale systematic shocks. So please join me in welcoming him.
So thank you very much, David, for your kind introduction. Thanks for inviting. My great pleasure to do it, say again. It is already third time we organize this webinar. The first one was during pandemic in 2020, and then I think in 2023. Now I'm more than happy to present recent insights related to academic and industrial perspectives of viability. And moreover, I would like to consider current developments in digital twins, in artificial intelligence, especially the agentic AI, how these technologies can help improve supply chain resilience and viability. And exactly, so we have direct connection to Michigan. One of the use cases I would like to show today, it's a use case of Ford, how digital supply chain twin was built at Ford. I think it's one of the first implementation of this scale when we look at supply chain digital twins. Yeah, so basically I would like to focus on supply chain viability and large-scale systemic shock, describing the concepts and then looking at technology which can help improve resilience and viability. Yeah. So essentially, I would like to start with a short introduction to define major terminology and differentiate large-scale systemic shocks from single-point disruptions. Then it will be some practical focus how to build adaptable supply chains in these very interesting, very dynamic, very turbulent times. Finally, I would like to shift focus towards simulation, towards stress testing of supply chains, look at which operations research and management science methodology can help improve resilience and how we can make stress testing. And finally, it will be sort of outlook toward agentic AI, which these new technologies, which implications this new technology have for resilience and viability. The main concepts I'm going to present today and main implications are based on a series of papers recently published in different journals. So I acknowledge this outlets and publications of topics related to viability, digital twins, and AI. I would also like to acknowledge our current funding projects from basically related to Made in Europe manufacturing programs, funding European projects about achieving resilience through manufacturing as a service, digital twins and ecosystems. Another project about serious resiliency in supply chain for Mediterranean region, and National Competence Research Center we got at our school in Berlin about challenges and resilience of global supply chain value chains from German Research Foundation. So the work I'm showing, it's a collective work where several research associates at my digital AI supply chain lab in Berlin have been involved. To start with, when we look at supply chain resilience, the traditional view of this topic is to look at firms' capability to withstand, adapt, and recover from disruptions to meet customer demand and ensure the target performance. Key determinants here are well-known time to survive and time to recover KPIs developed in collaboration with Ford about 10 years ago by Professor David Simhi-Levy from MIT and under direct collaboration with Dr. Oleg Gusikhin from Ford. So the concept is very simple. When disruptions happens, first we estimate time to recover, and then we estimate our available inventory, for example. And if time to survive, or how other people say time to shortage, it's shorter than time to recover, we get a problem, right? So we should start acting, we should start taking some actions, looking for alternative supply, for example, to avoid losses of supply chain resilience. And this is something what we name stability-based view of resilience, where resilience is understood as a quantity which we measure by deviations from some performance. Another view on resilience, it's an adaptation-based view, right? So understanding resilience in proactive way, trying to look at resilience as a quality and transit from react to act instead of react. So this is the main idea of adaptation-based view. From resilience toward business continuity, persistence of system performance in the presence of disruptions. Regardless of which view you take, I would like to stress that only a resilient supply chain can be profitable. And this simple but impactful insight could be very useful also for industry leaders who still look at supply chains mostly from cost efficiency point of view, still considering disruptions as something what it's exceptional, it's outside of normal business, and where we need resilience only for emergency cases. No, this understanding is wrong at the current times. We live at the crisis times where disruptions happens every day. So disruptions are no more external events to our business as usual operations. Disruptions are part of business as usual operations. So the only way forward is consider resilience from viability, from adaptation based. And this is exactly what viability, the main topic today, looks at. For the first time, we introduced this concept in the wake of COVID-19 pandemic with two papers which are currently are considered as seminal work in these areas. Our joint work with Professor Alexander Dolgy from IMT Atlantique in France, and my paper about the viable supply chain model. So these were the first two works which motivated a new line of research, and just recently I looked at how many papers were published according to Scopus statistic about supply chain viability. You see an continuous increase. So we can say that viability became a distinct topic in supply chain management, supply chain resilience, where novel and substantial contributions can be done in the future. And we already published 4 special issues, one of them in ISC transactions, two in Omega and one in production research. 2 other special issues are currently in progress, again in ISC transactions and also operations research. At the end of the webinar, I will give you some more details about the ideas of these 2 special issues. Yeah, so basically with viability, we look at systemic shocks. Right? In contrast to traditional resilience, which was mostly looking at single point disruptions like fires, natural disasters, strike, long-term crises have more severe consequences. They are considered as systemic shocks. Examples: tariff crisis, pandemic, or global semiconductor shortage. Right? So 3 main characteristics distinguish large-scale systemic shocks from single-point disruptions. First, the shock hits many echelons in the supply chains and propagates through echelons, so we have ripple effect. Second, it is rather a long period of time during which a system is under shocks. the up scaling and down scaling dynamics of which it's very difficult to predict. So it's not just a single point, hit and disappear disruption like tsunami. And third, knowledge about uncertainty in operations research models should be as limited as possible. Ideally, we should look at unknown settings, shifting the focus from predicting disruptions by probabilities or some risk scenarios to avoid system adaptability. I mentioned ripple effect. The ripple effect is a specific area of supply chain resilience research which look at the structural dynamics and disruption propagation in the supply chain network, leading to unavailability of components at different echelons and performance. One prominent example of the ripple effect was observed at the beginning of COVID pandemic, where closure of factories in China resulted in missing material deliveries at assembly lines worldwide and resulted propagation of these product shortages to the customer. Currently in Europe, exactly these days, we have also very interesting example for the ripple effect. One manufacturer of semiconductor in Netherlands have now huge problems with supply of semiconductors to European automotive companies. The reason for that is geopolitical tensions, tariff crisis, which we have now. So essentially some materials from China cannot be imported currently to Europe, and because of that, production of semiconductor capacity is significantly reduced, which immediately translates to production planning and automotive company. When I was reading the news today, the forecast is that in about 2-3 weeks, it can become very huge shortage of semiconductor in many European automotive companies, which would result in stoppage of many assembly lines. So these are examples of the ripple effect, and this is a very, very prominent way to look at systemic shocks, large-scale disruptions, and their propagation in the supply chains. So yeah, tariff shock was actually, and it's still a very, very prominent example of large-scale systemic shocks in the supply chains, leading to many ripple effects. We have seen a lot of ad hoc reactions of supply chains. And the question is, do we really have practical recommendations for supply chains to survive this global uncertainty and unpredictability? I think, yes, we have, and I would like to take a closer look at these capabilities which supply chains should develop to survive this turbulent time. One essential capability is the viability. Right? So viability is the ability of a supply chain to maintain itself and survive. So maintain business continuity, not just bounce back to pre-disruption state, like we used to look at disruptions in traditional resilience theory, to survive in a changing environments for redesign of structures and replanning of performance with long-term impacts. Right? So the viable supply chain model, which you can see, the conceptual design of which you can see here, there is also a mathematical part of this model, which in interest of time, I avoid to presenting here in detail. Conceptually, the main idea is to design adaptable structural supply chains for flexible supply-demand reallocations, and most importantly, to establish control adaptive mechanisms for transitions between different structural states. And you see that for different types of uncertainty, known, unknown, there are different ways to operate supply chains. At the times of, say, global stability, at the times of, as we had before pandemic, lean, agile supply chain design works very well. For single point disruptions, resilient supply chain design, it's activated using risk inventory, capacity buffers, or backup suppliers. And for long-term crisis, systemic shocks, survivable supply chain design is our main focus, which it's implemented by structural changes, by flexibility and radical redesign of supply base and logistics. There are 4 major elements which companies can use and researchers in optimization and simulation can look at when developing their studies. Four major capabilities to design adaptable supply chains. They are resilient operations, digital technology, resilient organization, and sustainable and human-centric network. While the latter it's a little bit outside of this talk, I would like to focus on resilient operations and digital technology first of all, right? So resilient operations means adding redundancy and flexibility to the system. We can do it using multiple diversified sourcing, resilient agile suppliers, omni-channel distribution, flexible manufacturing system. Look, in different parts of supply chain, we have different opportunities to design operations for everyday operations using flexibility principle. And this is very important. Here, we move away from predicting disruptions and considering disruptions as something what is external to our system. We move toward creating adaptability in everyday operations. And this adaptability, this flexibility can help us to improve our profitability. So considering resilience as value creation asset, not just as a cost driver. And at the same time, the same flexibility without additional investments can be used during crisis, during disruptions time. So our approach is to create adaptable supply chain networks for everyday operations, which are less sensitive to uncertainty. Value creation through adaptability, accepting risks and absorbing disruptions through designing structurally adaptable and functionally reconfigurable networks, accounting for unknown uncertainties. Redundancy, flexibility, and the third main component is visibility. Visibility is something what we now can achieve using digital technology, creating digital twins, using Internet of Things at the process level, and using different collaborative supplier portals, data spaces, and increasingly agentic AI, generative AI at the supply chain level. In one of my recent studies, which was done for request of a joint research center of European Union, I conducted literature review on the stress test methods developed and employed in supply chain. And this literature review has shown that operations research management science methods have been significantly used for supply chain stress testing. Methodologies vary. Most typically simulation and network theory was used for stress testing, followed by optimization and artificial intelligence methods. And when you look at how different methods complement each other, we can see that different types of supply chain analytics, descriptive, predictive, prescriptive analytics are used in supply chain stress testing. However, they are used in different ways. When our objective is to look at supply chain structure to understand connectivity, structural robustness, to identify some nexus suppliers and links, then network theory simulations are fully sufficient for such type of analysis. When we would like to look at the process level, right, adding some capacity, demand, inventory information, adding bill of materials, so adding product level, then we break down toward optimization and simulation and AI methods, when we can make dynamic stress testing, get the ripple effect, predict performance impacts of supply chains, and visualize how our supply chains would operate under different disruption impacts. And this is the general scheme, the general focus of how we perform the stress tests in the industrial and research projects we are involved with. The whole story begins with building digital supply chain map. In this case, we are using any logistics tool. This supply chain model is connected to risk data, which it's either historical data or increasingly real-time data, which it can be identified through network discovery using generative AI algorithms and other types of AI-based algorithms. And once the mapping of disruptions and supply chain locations shows that particular disruptions can hit my supply chain, we are running the stress test to observe possible performance impacts. The question is, how are we going to build the digital twins? Right? Unfortunately, not all parts of supply chain are visible for us. So there are parts of supply chain where we can really use object-driven approach, so bottom-up approach, where we build digital twins based on observation of physical object by sensing data from physical object. We can do it for some parts of supply chain, first of all, for intra-company supply chain and for tier one suppliers. However, deep tier network has much lower visibility for us, right? And in this case, data-driven approach should be used, where we start from data in digital ecosystems, and through data we recognize a physical object and create its digital twin, right? So based on some attributes, without seeing physical objects, we are able, with some good level of accuracy, to create a digital twin. And data-driven approach helps us to resolve very important problem, namely updating digital twins following changes in the physical system. Creating digital twin is difficult, but once you have created it, or even in the process of creation, the physical object will change, right? So it is a continuous process. As such, it is not just like building a house. You build a house and the house will exist in the same form for 100 years. No, a physical supply chain changes every hour, and so digital twins should do. Right? And with the data-driven approach, we resolve this problem without additional effort. So there is one paper in Omega, published in the new, very interesting area of Omega, International Journal of Management Science, new area which is named technology-driven operations. Very interesting new part of Omega Journal. And when we combining object-driven and data-driven approach, we can say that we have one part of supply chain where we can build digital twin immediately using object-driven approach, and another part, typically deep tier network, we just see it as digital shadow. You know, when I explain it during physical keynotes, I just say, okay, when I have my glasses, then I can see very well, right? So this is a part of supply chain. But when I take off my glasses, the screen becomes blurred, right? So it's everything is unsharp. So those of you who have glasses will understand immediately what I mean. And as I say with the supply chain, something which is close to me, I can see very good, but something far away in the deep tier network, it's like a digital shadow. And my objective for using data-driven approach is to make it sharp, to eliminate digital shadow, and to create digital twin of possibly large part of the network. How these principles developed conceptually are implemented in practice. With my colleague, Dr. Oleg Gusikhin from Ford, who is Senior Director of Global Data Analytics at Ford, we published new paper, which was published actually just 2 days ago, Supply Chain Digital Twin Design and Implementation at Scale, a case study at the Ford Motors Company Generalizations. I think it is the first literature which reports implementation of digital supply chain supply chain twin at scale. So first of all, we looked at the supply chain as visibility-driven network, and divided supply chain into 3 parts. Intercompany supply chain, where we have full visibility. Tier 1 network, where we have very good visibility, so digital twin design complexity is medium, and deep tier network, where visibility is low and digital twin design complexity is very high. So this is how we practically implement the first principle, object-driven and data-driven digital twin building. For intra-company supply chain and tier 1, object-driven network design is used, and for deep tier network, data-driven design. The second principle used in this practical implementation is deep tier network illumination. risk identification and mitigation process flow, right? With using AI technologies, it becomes possible to detect different risks, different disruptions from the news, for example, using text analytics, but also other techniques, not only text analytics, to identify target subtiers, to assess impact and ripple effect, identify supply size impact, and apply filters on target tier 2, and so propagating in the deep tier network. So this is the second principle which I described theoretically, network illumination, which is implemented in this use case. And finally, transition to data-driven digital twins, right? Starting from integrating data from ERP, MRP, TMS system, from third-party data using APIs and information which comes from sensors on the machine in Internet of Things environment. Supply chain digital twin is built, right? And it's built at different levels of detail. For example, for assembly line digital twin, we need a very high frequency of data updates. We need very accurate data. And this is something what should happen very dynamically, right? Because decision on production planning, on assembly line balancing are very dynamic. When we look at supply chain network design, here we have completely different situation. Here I don't need information update every day, and not every hour, maybe even not every week. I'm not replanning my supply chain network, every day. Even if currently this redesigning happens more and more frequently. Supply chain structures become more and more dynamic. But essentially, at supply chain network design, I need data at the point where I would like to run optimization simulation models. And here digital twins are of great help to deliver data, say, on demand, sort of data concierge, which brings data to decision maker to run optimization and simulation models. So basically, when we are generalizing this and other case studies, we can define 3 types of digital twins. The traditional digital twin, cognitive digital twin, which uses some elements of artificial intelligence, and intelligent digital twins, which not only replicate human decision-making logics, but also create new knowledge and decision-making algorithms for self-learning and human-AI collaboration. This is something what I presented many times. I would not like to go into details into this 3-level structure. What I would like to present today, and this is, I think, for the first time I'm talking about it for large audience, 4-level framework of digital twins and how we are moving toward agentic AI. And more precisely, the 4th level added here to the diagram, it's agentic digital twin. Interaction-based dynamic model building and adaptation using agent synchronization and orchestration. So essentially, agentic digital twin can be considered as AI augmented supply chain decision support ecosystem, which integrates data systems, generative AI interfaces, simulation models, and multi-agent orchestrations. Adding several capabilities like reasoning, interaction, creativity, synchronization, and adaptation into decision support models. And this is how this vision can work in practice. I would like to stress that this is a sort of work in progress, not the finished work, but I would like to share it with you just to maybe also to get your feedback on this when we will have a Q&A session after my talk. So the whole thing begins with the user, right? So just imagine you are a supply chain manager. You come to your office in the morning, you open your computer, and the first thing you do, you ask data concierge agent to inform you about the current state. What is current demand, what is current inventory, what is current capacity, and so on, right? So of course, it does not happen automatically. There is integration layer where we have data filtering and cleaning. So data scientists are of high importance here. And collecting data from different types of systems, the data concierge agent provides me an overview where we are today, right? But not only this, the data concierge agent can identify some problems based on the data found. For example, data concierge agent can take, in the last 3 weeks, we had permanent delays for material X from supplier A. And this can be an indication for me. So, so in this interactive way, the agentic environment informs you there is a problem in my supply chain when I would not be able to see otherwise. With that, using generative AI interface and my LLM agents, which essentially mimic decision-making logic of managers and sourcing and production and logistics, with the help of optimization simulation copilot agents, which I equip with MCP protocols, for example, with I'm asking the agentic environment, could you please develop optimization model or simulation model for stress testing of my supply chain for such cases, right? So this is a sort of creativity which is brought to discussion where even managers without any coding, without any engineering skills can create optimization simulation models. After models delivered some results, model is also able to reason, to explain solutions to users. And now, for example, we have a disruption, right? Risk agents inform alert a multi-agent system, not user, but multi-agent system, AI component of digital twin. Okay, there is a disruption. Then we have a simulation model for stress test using these operational agents. And depending on the outcomes of the stress test, multi-agent system can alert user, so human, or can make some adjustments in production distribution plans without involving a human. So this is a very, very advanced level of human-AI collaboration. Of course, there are many problems here, especially with generative AI, hallucination, trust in the results which you get, also problems in terms of if we equip every manager in the supply chain with possibilities to create own optimization simulation model, how does it correspond to centralized management paradigms? So a lot of questions here. Also a general question about AI, how much energy does it produce, and ethical questions. So all that I totally understand. However, I think it's not bad to look at possible future developments, and as it looks now, future developments in digital twins for resilience will be based on human AI collaborations. And the last topic I would like to cover is looking at supply chain resilience from biological system perspective, right? So each of us has an immune system, and each immune system has two main functions: to protect ourselves against viruses and to recover in case of if we get sick, right? And the same issue with the supply chain, right? On the one hand, we had something what they name innate immunity. Innate immunity means immunity which we are born with, some general protection like skin. And adaptive immunity. Adaptive immunity is something what we get during our life when we get in first time when we get in contact with a virus. Our body learns about this virus, and next time when we contract the same virus, hopefully our adaptive immunity will help to recover much faster. Or through vaccination, right? We can also increase our adaptive immunity. The same with the supply chain. We have some innate immunity like inventory, and we have some adaptive immunity like sourcing flexibility, production flexibility, and visibility. So here I have a reference to conceptual paper published on this topic, how immune system response mechanism can be translated to supply chains. And now in our lab, we are also preparing some agent-based simulations to develop modeling studies implementing this concept. Yeah. So if you are interested in this topic and the topic of viability, I cordially invite you to submit to two special issues. One special issue large-scale systemic shocks in manufacturing and supply chains in IC transactions, and another one on viable supply chain manufacturing and logistics analysis of operations research. Both special issues have deadline December 31. All right. To wrap up, to summarize key learnings from this webinar, currently we have a challenge that we have new reality. Not too many norms, not too many rules, not too many constraints, a lot of disruptions every day. And this increases exposure of supply chains to large-scale systemic shocks. Digital technology and resilience are transforming supply chains toward reconfigurable, adaptable, and resilience-centric networks. Right? We got a new context, supply chain viability, which builds on ready-to-adapt states regarding the unexpected, unknown. So viability perspective also extends state-of-the-art toward ecosystem and intertwined supply network view of resilience. Adaptation-based view of resilience, it's exactly what we use for viability, focusing on structurally adaptable system with process adaptability. Now, looking at resilience as something what we use in everyday operation and business unusual scenarios, and not only in emergency cases. And looking at resilience from the value creation perspective, and not from perspective of emergency and expensive cost driver. How to do it practically? There are multiple ways: create structural variety through multiple sourcing, increase process flexibility, for example, through alternative logistics routes, introduce some redundancy, but very specifically, not everywhere, right? Strengthen most critical parts of supply chains. And visibility, very important. Digital twins can probably help even more as redundancy, flexibility, and variety. So future topics are about agentic digital twins, biology-driven supply chain adaptations, and AI-driven supply chain resilience. That is, thank you very much for your attention, and I will be more than happy to have a discussion and clarify questions which you might have.
Yeah, thank you very much. We are open to Q&A questions. We have one question from Balaganesh Chandran. AI and simulation appear to be complementary and promising approaches. Can these methods provide insights into tariff-related issues? For example, if all competitors source locally or from countries with low tariffs, how does that impact supply chain resilience? And has there been any research on this topic, particularly regarding the effects of other agents' actions?
Yeah, indeed, I totally agree that AI, not only agentic AI, but different types of AI, generative AI, multi-agent systems, agent-based simulation, and agentic AI, they are all very relevant to supply chain resilience, very relevant to supply chain stress testing. And there are different areas, right? We can start with network discovery, where, for example, generative AI can be used to uncover ripple effect chains. You can just take an example, put yourself into position of a supply chain management. Somewhere in the news, you got an alert, there is a disruption, there is a fire of major supplier. First of all, you want to understand, does this disruption will impact your company or not? And for that, the first essential question is it your supplier? So is it supplier in your network or not, right? It is not your direct supplier, it may be tier 5 supplier. And here, generative AI can help to uncover this buyer-supplier relationships over many echelons, even in the deep tier network, to provide you with trusted, reliable information if this disruption is relevant for you or not, right? So the second question is, after you have identified, yes, this company is part of my supply chain network, the second question is when and how this disruption will impact your company. And for that, you should estimate two parameters, time to recover and time to survive, right? And here AI can help you exactly, right? For example, you can ask, when you have this agentic AI system, you can ask data concierge agent, could you please compute how long I can keep producing without having new deliveries of this material, right? So essentially, what is my time to survive or time to shortage? This is another application, right? And then after identification of this parameter, you can use AI to build simulation model, right? Or to adjust your existing simulation model for supply chain stress testing, right? So this is indeed a very important topic to introduce AI in simulations, but not only in simulation, also in different other areas of supply chain resilience, right? Disruption detection, ripple effect identification, and stress testing.
Yeah, thank you. Let's see. Here's a question. Isn't agentic optimization the same as compartmental old way of doing business? Like each agent, materials, logistics, production planning, finance optimizes its own benefit.
It's a great question. So so optimization and simulation are very powerful methods, right? And in research community, we all know about that. The problem is that optimization and simulation, well, maybe simulation is more practical, but optimization it's not very popular in industry. Right? Simulation is a little bit more popular, but even for simulation, its full potential uh, has not been recognized yet, right? Or recognized only in research community. In industry, so optimization simulation models seem to be very complex, very say rigid, very static, difficult to implement, difficult to modify, especially, right? And difficult to interact with, difficult to interpret results. So right. So and this is where AI can help a lot. First of all, AI can help to develop these critical capabilities of modeling, like interaction, reasoning, right? So that when you run a model, there are some AI capabilities which explain your modeling results. So you don't see just a matrix of not just assignment matrix or 0, 1 decision, binary decision variables, but where you really see a text which explains you in your management language why particular network design was selected, for example, or why inventory at particular warehouse should be increased, even if intuitively you would say, actually I would not do it, right? So it seems to be quite irrational, but this is how I can explain to you. And then, yeah, agentic, I would not name it optimization, right? It's not optimization, agentic simulation, right? So where indeed different roles in the company, like sourcing manager, production manager, logistics manager, can be described as agents, and using these logical rules, some simulations can be done without involving humans, right? Then, of course, it's a question. What happens next with result of this simulation? Will it go to decision making, so automated decision making by agents, or will it go as a recommendation to humans as decision making support? But essentially, I totally agree that this question is very important, and we should give a closer look how we design agent-based simulation, how we integrate them into decision-making processes in the companies.
All right. Another question. You mentioned designing resilience from a value creation rather than an emergency cost perspective. How do digital twins enable that shift in practice? Like, do you see specific metrics or KPIs that could help quantify resilience as a value driver?
Yeah, this is a fantastic question. Indeed, traditionally, we were mostly looking at, say, operational capabilities of resilience, like inventory, like multiple sourcing, like omni-channel distribution, flexible manufacturing lines, backup suppliers. And indeed, in many cases, developing such capabilities will increase resilience and viability. However, the key problem is that our visibility about network is very limited. Yes, I can add one more supplier for my tier one echelon, because I know my tier one suppliers. And for some of them, which I can consider critical, through different identification methods, I can create a backup source. But will it help me when I have a disruption at tier 5 supplier? Not too much, right? And this is a fundamental question and fundamental advantage of visibility. When we create digital twins, we do not really need all this redundancy, which is very expensive. But the key advantage comes from timely identification of disruptions and allowing enough time to adapt. Right. So this is a certain when you are asking about KPIs, along with time to survive and time to recover. Another important KPI, and this is a KPI which were introduced in a paper in ISC Transactions in 2024, co-authored with Alexander Dolgy, Oleg Gusikhin, and Casey Shteke. Time to adapt. Time to adapt is the next important KPI. So imagine a situation. There is a disruption at a supplier far away in the deep tail network. And you discover it immediately. For example, when you have a digital twin, you get alert within seconds after information becomes available. And then you can react, right? You can go to spot market, you can secure some stock, some inventory, some sourcing of this material. And you can do it because you are the first. When you do it tomorrow, when this disruption is announced in all media, in all news, many companies, also many of your competitors, will go to the spot market and trying to secure some inventory, but it can be too late, right? So this is how this time to adapt. It's essential KPI, which is directly connected to time to resilience, to time to recover, and to digital twins. Maybe you can remember at the beginning of pandemic, right? When it was announced that it will be lockdowns and shutdowns, everyone tried to buy more and more products. Maybe you still have at home some products which you took from the stores in March 2020, toilet paper or some cans, But when you came next day, shelves were empty. Because everyone who knew it a little bit in advance already took all the products from the shelves. The same as the supply chain. The faster you indicate the disruption, you identify disruption, the more adaptation potential you have to react.
We have a question from an attendee here that is along those lines. I'll read the question as is. To me, small disruptions and systemic shocks are similar in that they both include transition periods, difficult to handle. Long-term systemic shock ends with a new steady state, like COVID, that is much easier to optimize. Any thoughts? Maybe you answered this, but...
Well, so I would not say that there is really unique treatment of all single point shocks or all long systemic shocks. Even single point shocks can have very different magnitude and very different severity, right? So, and the question, I think the fundamental question is our knowledge about uncertainty, regardless of if we have single shock or long-term crisis. Because it's not about the duration, or not much about the duration of disruption, and even not much about its scale. It's about our understanding of impact of this disruption. Right? Take example of Suez Canal. You can remember Suez Canal, evergreen ship, 2021 blockage of Suez Canal. So in the end, it was single point shock, right? But it created huge impact. Why? Because we didn't know how long it will last. Right now we know 7 days, but predictions were, from 1 week to 3 months. How would you react when you have such a huge uncertainty about when you have such uncertain estimate of disruption duration, right? So this is the key question. The more we know, the better we can react, regardless of if we have single point shock or long-term shock. Now with tariff crisis, I mean, when it would be predictable, even if it would take many years, supply chain managers can adapt, right? But the problem is not the duration or not the magnitude, it's the unpredictability of scaling of disruptions during the crisis.
We have a question from Igor Linkov from the U.S. Army Engineer Research and Development Center about the definition, I think, of viability. So first of all, he says, great presentation and outstanding work. The field of resistance there's a lot of work in the field of resilience, and it is defined by U.S. national academies and government agencies as ability to recover and adapt. Mm-hmm. You basically define viability as adaptation under chronic stress, but doesn't the definition of resilience cover that? Like, why do we need viability? Basically, what's the difference? What is viability?
Yeah, this is a great question, and thank you. And obviously, you can intuitively imagine I received this question many times during different keynotes and talks. And this is very good that we have a question which motivates new discussions, right? So basically, there are different views of resilience. Yes, resilience presumes ability to recover and adapt. However, in most of the cases, resilience definition presumes recovery and adaptation with the objective to bounce back to initial state. And however, in most of the cases, during especially a long-term crisis, it is simply impossible to reach pre-disruption state, right? And for companies, I'm fortunate to have several collaboration with companies who work on resilience and digital twins. For companies, it is now essential to move from this, say, bounce back view of resilience toward something which helps them to ensure business continuity. It doesn't matter if I ensure my business continuity running pre-disruption state, or if I adapt to a new state. The most important, I survive. I can pay salaries to my employees. I can deliver products to my customers, even if it does not correspond to my initial plan, to my state before the disruption. And this is something how I understand the difference between the viability and resilience. And we can also look at this through the lens of biological systems, right? Biological systems are organized on one simple principle: to survive. They don't optimize their behavior. They never try to predict disruptions, right? They never have a plan that they want to keep and bounce back to which after being disrupted. Their main objective is to adapt and to survive. And this is essentially the key point of viability. So I hope this explanation clarifies a little bit what I have in mind when differentiating viability and resilience. That said, of course, there are a lot of intersections, and I am totally fine to consider viability as a part of resilience, or consider resilience as a part of viability. But essentially, we have these two major topics, right? So bouncing back to pre-disruption state and ensuring survival, business continues through adaptation.
I have a couple more Q&A questions. One is maybe a little bit more specific. How well is robust optimization accepted in industry, as in stress testing a network design through first simulating risk scenario variables and then solving for optimal networks?
Yeah. So the question is, how many experts in industry understand robust optimization? Right? Those of them who understand would accept it very well. But the majority of people, maybe I have worked with wrong companies, but my experience says me that even say deterministic mixed integer linear programming model can become a big challenge for supply chain stress testing and building robust optimization models. It's even more even stochastic models, stochastic program models. It's something for very advanced experts, and you see, not all supply chain managers have optimization simulation background. So yes, I would say acceptance could be better.
Oftentimes, increasing supply chain resilience increases costs. However, you mentioned early that resilient supply chains are more profitable supply chains. How do you balance the two between profit and cost? That's the question from the attendee. And I'm curious about the work that you have highlighted in the paper that was published a couple of days ago with Oleg Gusikin at Ford. Maybe you can answer that question in regards to Ford or other companies in terms of, okay.
Yeah, indeed. So I think everyone in this webinar can increase resilience of supply chain without big problems, right? Add some redundancy, increase inventory, add some flexibility, add some backup suppliers, maybe introduce digital twins. So you increase resilience. The problem is at which cost it happens, right? So obviously we cannot increase resilience of everything. It can really be very, very expensive. That's why the recommendation is to make analysis of which parts of your network are most prone to disruptions and which materials in your bill of materials are most prone to disruption. So to integrate this network and product level. And after that, to strengthen resilience exactly of these critical nodes, critical links, critical materials in your supply chain. And there are multiple ways, and this is something what we named lean resilience, right? Resilience which comes from value creation perspective. And some of them I highlighted in the presentation, mostly related to creating flexibility, adaptability, which help you to be more responsive in the market. So to increase your market share, to increase your sales. So essentially contributing to profitability of the company. And at the same time, this flexibility without additional investments will hopefully help you in the case of emergency.
I'll read this question. Professor, you mentioned that agility and lean can work perfectly to cover disruptions, but lean is based on just-in-time and make-to-order strategies. What about food, pharma, and fast-moving consumer goods?
Yeah, it's a wonderful question. Indeed, resilience, it's very different in different industries, right? For example, when we look at inventory, right? Inventory is considered an important element of lean, important element of agility, and important element of resilience. But inventory strategies are different across industry. In automotive industry, typical days of supply, it's about 30 days, right? So for 30 days inventory in automotive inventory, it's apart from just-in-time processes, but it's standard. If you look at pharmaceutical industry, in pharmaceutical industry, they have inventory for 6 months for components and for 4 months for finished products, right? I think they are very resilient, right? What sort of disruptions should happen that inventory for 6 months would not help you to stay resilient, right? Of course, it comes from other reasons, right? There are many special regulations in pharmaceutical industry. They have to keep such high inventory, even at the cost of efficiency, right? So in automotive industry, the regulations are different. But even here, we should be very careful, right? There are different types of materials and some also technological constraints. When you produce your car bodies from steel, I mean, steel you can store unlimited. But then when you produce your car bodies from aluminum you cannot have stock for many months, right? Just because of specific technological features of these materials. So there are many practical details when sometimes we overview in research when developing models.
All right, great. We've reached our time limit, our promised hour for this lunch. I want to thank you, Dr. Ivanov, for joining us. I think many of us will be in, I guess, Atlanta coming up for the Informs conference. So perhaps we'll see each other there. I know that there were quite a few attendees, many attendees in today's talk, many more than a typical Informs research session, but this is a welcome topic, and I thank you very much for joining us. I am excited to look at your new paper in Omega, and so thank you. So from our audience, thank you for a great presentation. I think we'll close off for today. Thank you very much.
Yeah, thank you very much, David. Also, thank you very much, Jason, Yisu, former leaders of Michigan chapter, for hosting this webinar. Thank you very much for audience for attending, for your great questions. Yeah, when you are in Atlanta at Informs, happy to catch up.
Sounds good. See you all then. Thank you.